Okay, so let's solve this question. The question states, consider the following ANSI C program. Students are going to see this ANSI over here and they're going to become a bit scared. What is this ANSI? ANSI stands for American National Standards Institute, right? ANSI C specifically basically means a multi cross-platform compatible standard on which C is based on, right? It is a pretty old standard and all recent compilers and C that you generally study follows this ANSI C. So when you study C language, what you are studying actually is ANSI C. So there's nothing to be scared about this. I'm just not just making this stuff up. It is, you can search on Google and it's present there also, that ANSI C is an abbreviation for this thing, something is something, no, wrong page, this page, right? ANSI C refers to the official standards version of C programming language. This one, another part which is important over here is this standard aims to ensure C language would behave consistently across different compilers and platforms, right? So that is one of the most fundamental funda of ANSI C. So it is very common C, and there is nothing special about this. Okay, so after that, what are they mentioning to us? Which one of the following options is correct? So the first option, let's see at the options. First option gives that the program will not compile successfully. Okay. The B option gives will compile successfully, C will compile successfully, and the output is going to be different. These three options basically give different kind of outputs to this particular output for this program, right? So first of all, judging your compilation, is it going to compile or not, comes down to two factors by which a compilation problem could come from. One is your syntax problem, a kind of syntax that the language has is not followed. At that point, the compiler gives a problem and it fails. Or a function is called without it being declared, right? For example, over here, printf is called in this statement. Now, you may say that there is no printf declaration over here. Yeah, printf declaration is not present in this file at first analysis, but look closely right over here, stdio.h. What does this stdio.h stands for? This std stands for standard, right? Standard, and this io stands for input output, right? So standard input output is handled by this header file stdio.h, right? And because it is handled standard input output, it provides you function declarations for scanf and your printf. So this printf over here is not being called without its declaration not being included. Its declaration is included by means of this include statement, right? So this particular statement is not going to give you a compilation error. Okay, so any other function calls happening in this main function? Not really. So this category of compilation problem happening is not possible. Now syntax mistake, that could happen. Now syntax mistake is kind of tricky because at every single statement, if at any point even a single semicolon missing at suppose at this statement is going to give you a compilation error, right? So you have to go through every single statement and be very punctual on that, be very serious on that, right? So just look at the first statement, hash include and then a header file. Include statement has a syntax like this, hash include, this kind of alligator brackets, inside of this header file name .h. So this part is followed very nicely. Okay, your main function has this kind of syntax. Is that followed? Yeah, this is followed. So this part is going to be, because this is the opening and this is the closing of main. Very good. Now over here, this is the declaration of these three variables, right? A semicolon is present at the end, so this is also good. A count is initialized to 0, I is initialized to 0, a semicolon is present at every single one of them. Now for loop starts over here, ends over here. Okay, for loop has this kind of syntax, initialization, condition, and then increment. So this j is initialized to minus of 3. Its condition that we are checking at each iteration of the loop is j less than equal to 3, and the increment of j. Fine. The for loop is following the syntax. Likewise, this if is following the syntax, and this every single statement you can see is having a semicolon at the end. And by clear analysis, it does not seem like there is going to be a syntax mistake. There is no syntax mistake. That is kind of thing which we can see very clearly, right? Now, so the first option cannot be the answer. Now B, C, D. From this, we have to judge what is going to be the output of this particular program. Okay. So so let's just analyze it from that point of view. We have I, J, and count. So I, J, and count we have. I count and I has been given the value of 0. Okay, j has been given the value of -3 and is going to go till 3. Okay, so let's write it down: -3, -2, -1, 0, 1, 2, 3, and it is going to go in this direction from left to right. Okay, so the condition that we are checking is if j is greater than equal to 0 and j I plus plus, count is equals to count plus j. Okay, so now come over here. The concept that is kind of important over here is short circuiting. And what is short circuiting? Short circuiting refers to what happens if when we use if statements in the program now, and there are two options that are being present with an and or a or condition, then an interesting phenomena happens. Suppose it is and. In this situation, if the first input was to be 0, then the second input becomes not important. Why? Because if it were to be 0, 0 and 0 is 0 only. 0 and 1 is 0 only. Right? Second input is not important, so the computer does not even evaluates it. Evaluation does not happen. Right? Evaluation does not happen. That is a very important concept in your language analysis, right? So this happens in many languages, not just in C, right? So right over here, in the when this a becomes 0, the second part is not going to be evaluated. But in our code, right over here, there is an increment operation over here, right? Increment. So this, because this operation is not evaluated, so the value of I does not change. But a lot of students are going to think that the I is incremented. This if condition is evaluated, so i's value is going to be different now. That concept, that understanding is plainly wrong. Because of short circuiting, I is not going to be evaluated whenever the first statement is not true. That is one thing, right? Now, because I must complete the concept that I was teaching. If this were to be or over here and the first statement, the first condition is 1 in this situation, and the logical operator over here is or, in this situation the second one does not becomes important, because 1 or 0 is 1 or 1 is 1, right? So in this also the evaluation does not happen. Once that part is very clear, now let's get back to this. What happens over here? Let me remove this part because it's becoming too cluttered for me to teach right away. Right? Let's do it. So when j is from -3, -2, -1 and 0, at that point, no, 0 will not be included in this list. -3, -2 and -1, this first operation is not going to evaluate to true. So it's going to basically lead to a value. This condition is going to produce 0, right? So because it is produced 0, so I is not going to be incremented, I is going to be 0 only. Very good. After this, when j is equals to 0, it becomes 1, it becomes 2, it becomes 3. Then what happens? When it becomes 0, at that point, this first condition is true. Now I is incremented. Now one more thing. When increment happens this way and increment happens this way, there is a difference. When increment happens this way, the initial value of I is used at the place at which this expression was written, right? And then the increment is done. But in this situation, the increment first happens and the value is then used at the location at which it was present, this expression was present. Because over here I plus and plus is mentioned over here, that means that the original value of I is going to come over here, and then I is going to be incremented and I is going to become 1. So a 0 is going to be dropped over here at this place. Okay, a 0 in C language, 0 is a numerical value. 0 is equivalent to false logic. Likewise, a non-zero value is equivalent to true logic. That's a C language kind of thing. This does not work like this in Java, but this does work in C. Okay, so now what? Now I must erase a bit part of this because this is going to become difficult if I don't erase this part, right? So I is going to become 1 and this internal condition is not going to be evaluated. Okay, now come. Very good. So now this 0 part has been done. So j being from -3 to 0 has been evaluated. Now when j is equals to your 1, at that point this condition is true. This condition we do not even need to focus on this condition at this point, because now for 0, 1, 2, 3 this condition is going to be true. Now for j is equals to 1, what happens? We come over here again. Let me remove this part. We come over here again, I plus plus, so I becomes 2. We go inside again. Count is equals to count plus j, so this count becomes 1. Then j becomes 2 at the next iteration. I is incremented again, so this becomes 3. Count plus j, so j right now is 2. 2 plus 1 is 3. Okay, then j becomes 3. At this point, I is going to be incremented and become 4. Count is going to be added to j, and that is going to produce 3 plus 3, that is going to produce 6. Okay, and after this, as all values of j has been considered, the for loop exits and we come over here, right? Right over here, count is equals to count plus I. I is currently 4, count is 6, so count becomes 10. Okay, after that the count has been printed out over here, and the output and the code base, the main function ends over here, right? So the output of this particular program is going to be equal to 10. The option B over here matches this output, and that is going to be our answer, right? I know that this required a bit of practice with your C language, a good amount of practice to solve it correctly and without error, right? If you are not aware of all the dynamics that were required for this question to be solved, then it can produce a lot of negative marking. Very easy to produce negative marking in this. It was difficult because of that, right? If you have some doubts, if you don't believe that this analysis is correct, and obviously if you run this program, how would that operate? Well, I produce the same code inside of a computer editor, right? And I can produce the answer. Let me delete the answer that has been produced, and let's run it again, right? This is run and the output is actually indeed 10, right? So it's a very simple question if you know C in a good detail, right? And I do hope that this particular video gives you confidence in your own solving ability, because as is present from this analysis, the output that we got from the analysis is same as what the program produced when it was run on a computer, right? And with that, I will see you in the next video. Thank you.